Hello everyone, it's June the 14th. Alright, June the 14th. Let's do this. What are we looking at? Is it right? June the 14th? Yes, it's right. Okay, so this is the one for today. Longest string chain. You're given an array of words where each word consists of lowercase English letters, okay? Word A is a predecessor of word B if and only if we can insert exactly one letter anywhere in word A without changing the order of the other characters to make it equal to word B. For example, ABC is a predecessor of ABAC because we can insert exactly one letter anywhere in word A without changing the order of the other letters to make it word B. Well, CBA is not a predecessor of BCAD because we will have to change order. So we insert one letter into the word such that the word becomes the second word. Exactly one anywhere. So just exactly one we insert it and that becomes a predecessor. So a word chain is a sequence of words where word 1 is a predecessor of word 2. Okay, a single word is trivially a word chain, yes. The length of the longest possible word chain with the words chosen from the given list. So we can choose anything, right, in any order. So we have A, BA, or BCA, BDA. That's fine. BCA and the BDC also works. Okay, we have 3 examples. Ooh, any ideas? I'm thinking right now. Hold on. Get my trusted paper. Honestly, no idea. But one thing is for sure. The length of the letter increases, right? So if you want to go, it has to go from small to long, right? And we have 1,000, so the length is not an issue. But what we want is we want to find the longest. Okay, we want to find the longest, and each one can play a part. Why don't we go from right to left? No, why don't we just get the length first, right? So let's say example 1. Length is 1, we have A and B. Length 2, we have BA. Length 3, we have BCA and BDA. And length 4, we have BDCA. Okay, so that's that. Now, from left to right, if it's a chain, we need to add one letter anywhere in it. But if we go from right to left, that's just to remove a letter, right? And it's much easier to remove a letter than add a letter, because you add a letter, you have to choose which letter to add. It's a little bit more complicated. But if we want to remove, we have the original letter there. We just see when we remove if it exists in the previous level. So for example, I have BDCA here, right? And because each letter is about 16, so we can create a new one very cheaply. So just remove one. Let's just remove one by one, right? We remove B. Now we have DCA. Then on the level 3, which is fine. Is there a DCA? There's no DCA. Okay, it's fine. And then we remove D. We have a BCA. Oh, we have a BCA. Perfect. We put that in the queue. Then we kind of already realize it's going to be a breadth first search. And then we remove C, BDA. We have BDA. We remove A, BDC. We don't have a BDC. Okay, so on the next level, we have both of this, right? Then from the first one, remove B, C, A, no. Remove C, B, A, yes. Remove A, B, C, there's nothing. Remove B, D, A, no. Remove D, B, A. We'll put it in B, A as well. Right? Put it in as well. And you realize it could be a set, right? It could be a set instead of a list. It could be a set, and then remove A, B, D, nothing. Now we have B, A, and then we do. So yeah, we just, if at a certain level, okay, we don't have anything. So it is also possible, right, that we have something in the front and we get to something and we can never get to the next level. But on this level we can. So what we're trying to do, right, what we're trying to do is start from the rightmost, right, and then we will create a list, a queue, right, the next level queue based on that. But in addition, we should also add whatever is in there into it as well. But they will be labeled differently. So when we push it in to this queue, it's more than just the word, right? It'll be a word attached to the step, how many steps we have done. So by the end of the day, we just want to find the longest step. So this is my solution. I have an idea. Okay. So if you like kind of want to deconstruct the whole process, I think the most important step is realizing that we should go from right to left instead of left to right. And of course, other than that, what else are you looking for? Looking for default dict. And we're gonna go through the entire thing. We're gonna say, what we call it, length would, like that. Okay, default dict, and I want to set. And they say for W in words, len words, len W dot add W. Okay. So now that we're done, we're going to do some sort of BFS, right? So we have to have a res. We want a maximum, so we go with 0. And then we need the initial. Should be the maximum, right? The initial. Hold on. So how do we do this? So we find the maximum length in len words. Take it out. Yeah, so that would be the Q, right? Hold on. The Q. Do you want to use Q or do you want to use visited? Maybe using visited is easier. Okay, so anyway, what we want to do is to find the maximum. Find the maximum on the len words. That gives the maximum length. And then we say len words, this thing, give us all the words. Then we just go for W in these words, and we're gonna create W and 1. Okay, so these are the initial, right? These are the initial words. Okay, which is perfectly fine, right? Perfectly fine. So now what do we want to do? We want to visit it. Now we call it included. That's going to be a set. Okay, then we say while q temp. Okay, and then we say for w, and we call it step in q. Okay, so for each one out, we got L equals len W, right? That's fine, we don't have to do this. What do we want? Right, what do we want? What we want is for this word, we will remove every single one and to see if someone exists, right? Okay, so what we say is for I in range len W, right? Oh, rest should be 1. Unless we don't have any words. Now we have at least one word. Okay. So for I in this, then we say candidate shall be W to I plus I plus 1 to the end. Right? We just remove I. So that's the candidate. And we say if candidate is in len words len W minus 1, right? If this in this, and candidate not in visited, right? Because if it's already in visited, that means it must have a higher value. Then we just don't include it. Then we say temp dot append candidate and step plus 1, right? Oh, of course, res equals maximum res and step. Every time we get 1, we just update the res. Okay, right, that's that. So for each word, we will splice it up and see if it exists in the next one. And blah, 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 blah. Once we're done, right, once we're done. Oh, and I forgot, we're going to say visited.add candidate. This one has visited, right? So we just don't visit again, right? Don't visit again. Okay, so blah, 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 done with the current word, right? Now we go for the next word in the queue. So for everyone, we repeat this process. Right, we'll repeat this process until we're done. Then we say q equals temp. Oh, hold on. We need to go through to see if there's anything remaining that has not been added. Then we just say for W in len words because we go one step at a time. Right. So what's the current length? Yeah, let's let's call this. Okay, so we have a length. So this and then this, and this is going to be length. Right, and it'll be length. blah blah blah. Once we're done, and then we'll say length -1. We see if there's any word. Let's say if w is not in visited, then we say temp.append w and 1, right? Because they have not been visited. It's the first time. And then visited.add candidate. No, add w. Ooh, visited. And it's never visit. I say included. Jesus. Visited. It's actually fine if you think about it, because we go for the lower one. We never visit again. Right, the top one we never visit again. We could just get a new visit at every single level. Yeah, because we're going down. In this case, I might just do this, because we go one lower. If it's not in, we just add, just to make sure we don't add the same value. Right, we say if it's not in visited, then we add it, and then we don't have to do this. Okay. So after doing this, right, after going through 2 rounds, then we say if not temp, right? If not temp, if we still, like if we have a missing level, right? If we have a missing level, then everything stops, right? Everything stops. We will have to keep going until we find a new level. How shall we program this? I think this shall be while length. Yes, it should be while length, and temp is this, right? And then for things in queue, I get something out, and I have nothing. Okay? If it's nothing, what if it's nothing? What if we don't have temp? Queue is nothing. Look at this. Because, which is fine, which is a queue equals temp and length minus equal 1. Right? Then we go back. Temp visited, queue is empty, which is fine. Then we just do this. Right? We do this. Length minus 1. And if it's still empty, it's fine. We just keep going, keep going, keep going. I think this is fine. Now, we might be able to include this inside as well. So instead of setup queue here, we can simply set up queue as an empty, and this is going to be +1, right? And we can just say for length in range max len words +1 all the way to 0. Alright, and then temp is empty, visited is a set, empty set, and then first queue is empty, right? Then length -1, because length is maximum, so now we have maximum. We put some in, right? We'll put some word in, and then go back, and then we say temp equals length, and this one is not necessary. And then we'll actually hit. That's the first one we hit. Now we update the result, and then for each word we will do candidates, and then blah 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 blah. If there's no more candidate, we put in until we go, we don't have length anymore. And once we're done, and remember the length of each word is 16, so this one at most runs 16 times, and then we return rest. That shall be it. Alright, so we have a couple of examples. So this one shall give us 4. This one shall give us 5. And this one shall give us 1. Words. Try it. Seem to be legit. Try here. I just throw some. Let's see what we can throw. Like I want to throw something like this, right? That should be 1 because it's skipped. Yeah. So hit it. Boom! 1 shot. 1 freaking shot. So that is an improvement to me. So how long have I been doing this? We've been doing this for 22 minutes. Okay, that's a 22-minute trial. Last time was May the 17th, 2021, and I hit some pretty rough run until I figure it out. But that's probably not a good decision. And then I probably check the results to see this. So that's like an hour. Okay, so we solved a problem that we used to solve comfortably, not comfortably. Solve like reach a certain. I mean, it's about an hour, right? It's about an hour. And today is 22 minutes, so that's an improvement. I didn't remember how to solve this, to be honest, but the intuition came to me pretty straightforward. Like I said, the most important intuition is to go from right to left. And the reason I thought about that is because going from left to right, there's just too many options. Going from left to right, what you're trying to do is you have to pick 1 out of 26 letters and then put in 1 of the positions. So that's a lot of combinations to try to see if you can reach any of the letter on the next level. However, if we go from right to left, you're deleting. So the template is set. The template is 16, right? It's a 16 length. You just take 1 away, take 1 away, take 1 away, and just put the string together, and then you check. So it's much less. It's 16 times, 16 checks versus 26 times however many spots you can do. So that's a much, much easier way. Now, is the other way not going to work? Probably not. Probably that's what this 952 milliseconds is. The other way I think will work because there are only 26 letters, and at most 16 or plus 1, 17 positions. So for the most word, you have 17 times 26 different tries. It's not that big, right? It's not that big. So you can still, if you want to work from left to right, you can do that. And then we use the same technique on the BFS. But going from right to left, definitely make everything look much easier, and then it clears out your mind. And then the BFS idea came pretty naturally. Okay, I can write a summary. Good. I don't remember which one is this one. 1048. So the key of the solution, right, is going from right to left because it reduces a lot of the search space. Also, the BFS idea is quite straightforward, right? Quite straightforward from the question setup. So the runtime, well, let's say it's called OM. Well, that's ON, the number of words, and OM is the length. And we are doing, we get every word once. So we call it OMN, okay? Where M is the, let's say, call it average length of the words. And N is the total number of the words. Now I'm kind of ignoring this. This is actually whatever it's gonna be. So technically, this is squared. Yeah, we probably should do square, right? Yeah, I think it's OM squared. OM squared here. Oh, does that mean previously we had a better solution? We'll see. So this was the 900 milliseconds. What's the slow one? What did I do? Did I go from left to right or right to left? Left to right. If you see that, I sorted it so it's only left to right. No, I am removing. Oh no, I'm removing on the next one. I'm doing a graph. Huh. Okay. Anyway, so that's that. This is the 120. Oh, hold on. Wait, I didn't click open this one. I want to see the difference. DP solution. Ooh, this one is simpler. For each word, we find all of its possible predecessors and then look into the DP table to see the maximum length of chain ending at the predecessor. We pick the largest of the max length plus 1, then store in the DP table. We can sort the words, okay? So we have each word is the maximum length, right? We have the maximum length for them, and for each one we try to see if it's equal. Wait, hold on. So for each one we have a pre, and then we say if it's, oh, I see. Oh, this is actually still better. 79, so I have one more. I have to say the DP solution is better, simpler. Alright, let's call the DP solution out. So this is the DP solution. I have to say that it is better and easier to code than the BFS. So the DP solution will have a DP, we start the default dict with the int, right? And then we store the words, and we need a minimum length. Yep. So we have, say, sorted words. Maybe we can just say sort. Words.sort. Key equals lambda word len word. Okay. Min length equals len words 0. Okay. And we say for word in words, right? If len word is equal to main length, then dp word equals 1. Okay. Else that's larger, right? And then when we say for I in range len word, candidate equals w I plus wi plus 1, right? And then we want to find out the maximum length that they have. So dp w shall equal to maximum dpw and dp candidate plus 1. And then blah, 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 we go through every single one, we get a maximum of this, and then keep going, and then we then return dp, and it shouldn't be return the maximum, right? The maximum of dp.values. Okay, let's see. Yep, so we got this one too. Not this one. Yep, I do think this is a better solution. Same, the runtime is the same. Time complexity, same as solution 1. Okay, so that's that. All right, let's get down to this one. So we had an idea from last time, but we were not implementing it well. Okay, so I don't think we even started this one yet. This is, yeah, we haven't even started this one yet. So I have the idea to, basically it's DP, right? We built it up, and all we want to know is, given a certain length, right, what is the number of different ways we can get. That's the thing. And all we have found out is, instead of counting different ways, we should separating them, right? And given certain number, now we can separate them, and then we can say how many choose how many. Like that's what we have found out. So I need to fully flush out this idea. I need to just kind of go back. Wow, it was like 2 days ago. So I have this, right? We have like 4 And then we have 4. We want to find out, we have 3 positions we can put, right? So it's going to be C3 choose 3, C3 just 3 choose 3, 3 choose 2, and 3 choose 1. Because the maximum for them is 3. So 3 choose 1, which means these two, the difference cannot be less than 2, right? So we're going to do 3 choose 1. I'm on 1 and 2, so 3 choose 1. So that's for 4, right? We say for 4, we have 3 positions, so 3 choose 3 plus 3 choose 2 plus 3 choose 1, right? And that's it. And then with 4, we can now do another one. So what's 4? 4 is supposed to be man, I need to copy this. There's some good test case right there. Hold up. Yeah, the TDD. TDD, man. Are you crazy? So this is 1. Okay. This is, how much is this? This is 2. 1, 2, 4, 7, right? This is 2. And this is 4. And this is 7. Which is right. Which is correct, because 3 choose 3 is 1. 3 choose 2 is 3. 3 choose 1 is 3. That's 7. Yes, exactly. So the idea is to build this up. We need to build this up. And that's 5. So 1, 2, 4. No, hold on. 1, 2, 4, 7, 13. That's 13. Okay. This is 24. This is 44. Okay. This is 8. And this is Gordy. That's a large value. All right. Let's do this. Okay, mod is fine. These are all fine. And we need a function, right, to compute when we reach a new height, not new height, when we reach a new length, right? We need to find out the new length. Then we need to go down. I think a DP table is better suited for this. I don't know how many we need, right? How many do we need? Now, for example, we have to do 5, right? No, this is 5. So we have 4. So we have 4 choose 4, 4 choose 3, 4 choose 2. That's the most we can do. We cannot do 4 choose 1, right? We cannot do 4 choose 1. But what we can do, so instead of doing 4 choose 1, what we can do is 4 choose. Wait, I can't do 4 choose 1. I can do 4 choose 1. It's just when I do 4 choose 1, it cannot be anywhere, right? It cannot be anywhere. Because when I do 4 choose 1, I have to say basically it's the 4 situations. Wait, hold on. I figured it out, but it didn't make sense now. Hold up. So 4 choose 1. I can do that, right? I can do that, but that 1 has restriction. I cannot put the first one. I can put in the second one. I can put a third one, right? These 2 situations. So what's so special about these? Yeah, what's so special about these is we are restricted on where we can put. But how did we compute this? How did we compute? Well, we know when we do this, we have to go to, so we're doing 5, right? We have to go to 4. And then we need to do 4, like 1 separation in 4. Like all the ways 1 separation in 4 works, I can make it work here. And we say we separate 1 out, and then we just do 4 choose 1, okay? And then we separate 2 out, and then 3, 2 choose 1. Oh, you separate 1 out, you cannot separate 1 out. So this is not working. So we basically say, if I separate 1 out and then remaining 4 is not going to work. So it's not possible. So only possibility is I separate 2 out. So I have remaining, we have 3, right? So basically for 3, I want to say I give you 1. It's not what I was thinking. Maybe I'm not. Because I have 1, right? If I have 1, then if 1 doesn't work, so we just go 2. 2, 3 works. And 3 and 2 are so the last position is 2, right? So this is what we build. 1 is going to be, so the DP table is like this, right? First, we can do all 0, it's fine. Position 1 is just going to be 1. One is going to be 1, 2. Say how many separations we have. So 1, we have 0 separation, right? Have 0 separation. 2 have 0 separation. 2, if we have 1 separation, that's just 1. Right, 3, we have 0 separation, is going to be 1. 1 separation is going to be 2, and 2 separations is going to be 1. Yeah, 1, 2, 1, and so that's 4, right? If we go 4, what do we have for 4? 4 is going to be 1, 3, and then 3, because we cannot do 4 with 3 separations, right? If we go 4 with 3 separations, no, we can't do 4 with 3 separations. This is going to be 1. We cannot do 4 with 0 separations. In sum, right? In sum, we cannot do. So the 0, 3, 3, 1. Now we go 5. And then all these are going to be 0, 6, 7, because they cannot have 0. So I have 1 separation. 5. Let's now go 1 side. Let's go 4 separations, right? So for 5, 4 separations is going to be 1. 3 separation is what's that? 4 choose 3. 4 choose 3. That should be 6, right? 4 choose 3 should be 6. No, what the hell? 4 choose 3 is 4. How is that 4? 4 times 3, right? 4 choose 3. Yeah, it is. It is 4. Because wait. How did, what's the formula again? I forgot the formula. Oh, right here. Oh, okay. So 4 minus 3, 3. So that can be n minus 1, that's under 1. This is going to be n minus r, n minus r minus 1, 1 times r minus 1, 1. So all these can cancel out with this. So just n times n minus 1 times all the way to n minus r plus 1, right? Divided by r factorial. So in my case, so it's just going to be n minus r plus 1. So 4 minus 3 plus 1 is 2. So 4, 3, 2 divided by 1, 2, 3. That's not right. Something is not right. Something is not right. Hold on. Oh, I think we're thinking about the permutation. So 1, 2, 3, 4, 1. Oh, yeah, it's right. It's 1, 2, 3, 4 divided by n minus r. So it's 4, 3, 2, and a 1, 2, 3. That's 4, right? So it's, so choose 3, and then be 4, 3, 2, and then on the bottom is 1, 2, 3. Okay, that's fine. So that's 4, and that's 4, choose 3, 4, choose 2. Now 4, choose 2. Oh, go 3 times, go 2 times. 4 times 3, and 1 times 2. That's 6, right? And then now we want to say one separator, right? One separator. So we have 5, 2, 3, 4, 5. Now we have one separator. How do we handle this? Well, what we can do is we say this one separator. How does it work? One separator for that is 2, because she's a 2, 3 or 3, 2, right? Okay, so we're going to put out 2. And so how about 6? Now we have 6, right? And now we have 5, right? That's 6. We have 5. So go 5, choose 5 is 1. Okay. And if I choose 4 is, come on, 5, choose 4 That's 5, right? And if 5 choose 3, that's the most we can do, 10. Now we need 5 choose 2, right? But, which means we have to go 2, but we cannot go 2 because we cannot. So basically, what we say is, how did we figure it out last time? I can put 2 in there. We can say we put first one, then we need 1, 2, 3, 4, 4 with 1. No, we cannot say that. That's actually 1. If we put 1 here, right, then the other one is going to be 5. Okay, so let's analyze. So if we have 1 out, right, then in the remaining, okay, so we have 2, right? We have 1 out, and the remaining we need to find 1. Man, what's the rule here? Oh, it is. If we have 1 out, then the remaining is a 5. We have 5, and then we have 1 separator. So just 5 with 1 separator. Yeah, I don't know what I was thinking. Yeah, and then with 5 is the same. Right? We have 1, and just 4 with it's just 5 with 1 separator. It's 4 with 0 separator. It doesn't work, right? And now we put here 3 with 0 separator. That's 1, right? I put here 2 with 1 separator, 0 separator. That's 1, that's 2. Now it makes sense. Now it makes sense. So we put here, it's 5 with 1 separator. Now we got 2. Okay. Now we put here, that's 4 with 1 separator. So 4 with 1, that's 3. And then we put here, that's 3 with 1 separator. And 3 with 1 separator is 2. So add together, 2 plus 3 plus 2. Oh, it's with 1 separator. Yes, with 1 separator. So that's, how much is that? 7. 2 plus 2 plus 3, it's 7. So that's 6 element with 2 separators, 7. Now 6 element with 1 separator. Okay, so again, we go to the first one, it doesn't work because we don't have a 0, right? We have 0, so we have to go all the way to 0. We can find who has at 0, who has at least a value. Well, we have to go 3, so we can go 3. So we have to go 3, we put 1, 3 has 1. So that's 1. So 6 with 1 separate, that's 1. Okay, so for every one, we can go from right to left, just work through And we have to build this all the way? No, we don't have to build all the way, because from 7, okay, from 7 we go 6 first, right? So it's shifted, right? Each one is just slightly shifted, slightly shifted to the right. And when it's 7, it's gonna be 6 choose 6. That's still gonna be 1. And then 6 choose 5. 6. 6 choose 4. That's it. 15. That's all we can manage. 6 choose 4, right? Now 6 choose 3. We don't have 6 choose 3, but we have 7. Right? So we put 1, so it's gonna be 6. We choose 3. Right? It's 3. So we just go 6 choose 6 with 2. That's 7. 5 with 2. That's 6. 4 with 2. That's 3. That's the most we can do, right? Because we can go 7 minus 3 is 4. Yes, that's the most we can do. 7 minus 3 is 4. Because we do one more, then we blow up. So we go up at most minus 3. Okay? We go up at the most minus 3. And then 7, 6, and 3. That's 16. Right? That's 2 separators. No, it's 3 separators. 3 separators. Bad table I've been drawing. Right. Now we go 2 separators. Okay, 2 separators. So again, with 2 separators, we take 1, that's just 6 with 1. It's gonna be 1. 6, 1, 5, 1, and 4, 1. So that's 1, 2, 3. 1, 2, 3 is 6. So 7 with 2 is 6. 7 with 1. And that's a 0. Cool. That's it. So 7 is going to be 6 plus 16 plus, is that 15? Yeah, I think it's 15. Plus 6 plus 1. 44. 1, 2, 3, 4, 5, 6, 7, 44. Yes. So all we need to keep is, we have different. So for these, we just need to keep 4. How do we keep 4? So the new one, we just ditch the old one. I see. A deck. We'll use a deck. We use a deck. Oh, this is going to be super interesting. Yeah, I'm going to finish this today. Otherwise, tomorrow, I think I'm going to forget about this. Okay? We'll use a deck for this. And we're going to build all the way up to the maximum. So we're going to find out. So now and then we say from into tools, import group by. Okay, use group by. Here's what we do. We're going to say the length and the keys. So press the keys, and then we just say key and the length, right? So that's going to equal to for key and group in group by pressed keys, right? And then we know one is key and length of list of G. Okay. So this is going to be something like that. Oh, I forgot. Another one. Okay, so that's that. And now what we're gonna do, we want to find the maximum on the length. Oh. Max length equals max L for this L in key length. Okay, so I have max length. So basically just build up a DP table for that. And so DP, so and most, we're gonna keep 4, right? Keep 4 because for different numbers, it's different. How do we do this? Because we have 2 keys that's allowed. The 2 keys allowed for 4 strokes. Right? 2 keys allowed 4 strokes, which is 7 and 9. Everything else is 3 strokes. Which means for everything else, I don't want to build. No, I think I have to know. So I need to build 2. We need the 4 stroke, right? Or the 4 stroke or the 3 stroke, they're different. Okay, so I'm gonna say 4 max length 4 and max length 3 equals 0 and 0. Okay, and for this L in key length, oh, I actually need a key. So for this in key length, if key in that is not, that's going to be 7 and 9, right? If it's 7 or 9, max length 4 equals maximum max length 4 L, that's the length, else max length 3 equals max length 3 and L. Okay, so we have the maximum length. That cannot tell me how far I need to go, right? It tell me how far I need to go. And we need to build 2 decks. Okay, we need to build 2 decks. Now we're gonna build the max length. It shouldn't matter, right? It shouldn't matter. So what if we just I'm gonna say DP. Wait, what? We don't need this DP. All we need is different length. How many possibilities at different length? So we'll call the library. So library for 4. All right, that is going to be, I don't know. So we just call it 0, right? Times max line 4 and lib for 3 equals 0 times max line 3. Actually, we're going to plus 1. Okay, and now we're going to write a function. Okay, so def build lib. So what do we have? We have the lib, which is going to be a list of integers, and we have max length, right? Max length is an int, and we're going to say max repeat. That's going to be int. Okay, so this one we're going to return no, we're not returning anything. We're not returning anything. Oh, in this case, why do we put this one? We should just return a list int. Right? Forget about this. We don't need this. All right. So max length and max. So we're going to say lib equal to 0 times max length plus 1, right? And then we can easily fit. Right? We say for well, I want to fill at least up to 4. So 1, 2, 3, 4. I want to fill 1, 2, 3, 4. Right? I want to fill 1, 2, 3, 4. So we say if max len, because with 4, 3. Well, let's fill it all the way to 3. Right? Let's fill it all the way to 3. Because 4 is where we start to have difference, right? So we say, now let's just go here. I'll say if max len is smaller or equal to 3, okay? Then I'll just return 0, 1, 2, 4. Okay? No question asked. That's the end. Now if a max length is larger than, then we do this, right? And then we will prepare, right? We will prepare our thing. Now, how do we prepare our thing? We're going to prepare a DP. It's going to be a deck, okay? But a deck is going to be something like this. So that's our 0, okay? And then that's our 1. So 0, 1, 2 is going to be 1, 1. And 3 is going to be 1, 2, 1, right? We also need factorial. So I'll say from maths, import maths. I'm not sure. Yep, I have factorial. Yep. All right, so we just import math. So deck is going to be this, okay? Now what we're going to do is we have a new thing coming and then go 1, 2, 3 or 1, 2, 3, 4, depending on the maximum repetition, right? So what we're going to do is we're going to go all the way. I'm going to say for I in range from 4, right, to max len. We have to go all the way to max len. Then we simply say actually we don't. We're gonna do this. I'm not gonna do anything. I don't even like this. I'm just gonna return lib. Okay. Otherwise, we are going to produce something, right? Something need to push into the deck. Right? Push something into the deck. Now, how do we push something into the deck? We call it a temp. Okay, temp equals this. Now we are going to push however many things that we think, right? So based on the maximum repetition. Now the max repetition determines, so if it's the 3 max repetition, and then I have the current is I, right? Then we just say for a j in range, so it's going to be I minus 1, right? That's the number of separation, the maximum of separation we can do, all the way to I minus 1 minus max repetition. So think about if I equals 6, I minus 1 is 5, right? And 5, the max we can do is, so 5 minus, that's 3, max rep is 3, that is 2, but we cannot hit 2, so this is 5 for 3, right? But if max rep is 4, so we can actually hit one more, so that's going to be j. Then temp dot append, so these are free given, right? So we append math dot factorial something. So what's that? Math dot factorial, if I remember right, that's I minus 1, right? Divided by math dot factorial something times math dot factorial something. So what's the first something? First something is I minus 1 minus j. Now, this is dangerous because when we're supposed to go from j. Oh yeah, it is. This will be 0, right? That will be 1. And then this will be factorial, I think that's j. And because it's the same, so that's 1, right? So these are given, right? These are given. So from basically 3 choose 3, 3 choose 2, 3 choose 1, right? And of course 3 choose 0, right? 3 choose 0. Yeah, because for max rep, the 3 choose 0 is perfectly fine. It's perfectly fine. Now after the free given, and then we might have something left, right? So what is something left after this? So j can take I minus 1, j take to 3, right? In this case, j take to 3. So after doing this, j, let's keep j minus equal 1. So we're going to start from this position, right? We're going to start from this position. And to see, we say while j, okay? While j, then temp while j, right? And we're gonna add them together, right? Add them together. How do we add them together? What is j? J is the number of separations we are allowed right now. Okay, so now what we do is so while j is the number allowed, so we'll take one, right? We take one, and I minus oh man, j is the remaining we have. No, j is the remaining we have, right? So for each j, I will just get 1, get 2, get 3, right? So for each j, now we need to go for basically for allowed, that's allow 1, that's allow 2, allow 3, and then we can allow 4 in certain cases. So for k in range, basically it's just 1 to max repetition, right? There's 1, 2, 3. And I minus 1 is the current number of possible slots. And this thing minus k is the remaining slot, right? So we can take 1 slot, 2 slots, 3 slots, right? Or 4 slots. So that's the remaining. Okay, that's the remaining. Now, what we're going to do is this is the remaining, and the k is growing, right? So this is the remaining number of open slots, right? So remaining number of open slots, and I have j minus 1 number of separation available, right? J minus 1 number of separation available, and we need to find out how many there are. So this is the remaining number of slots, and what we can do is the current number of slots. What's the current number? So I minus 1 is the current number of slots. So if the current number of slots, I don't know, count how many times. So if current I have 5 slots, and now we have 4 slots, so we need to go up by 1. So we say the current number of slots minus the previous number of slots. That's the number of steps we need to go back up, right? And then this just means it's going to be k. That also means it's going to be dp minus k, right? dp minus k. What is k? K is the number that we are, a number of slots we've taken, right? Taken 1 slots and the remaining, yes. So dp minus k, so initially put minus 1, so that's just the end, which is the one above us. And this is going to be j. J is the number of, oh man, what is j? J is the number of slots. Wait, hold on. Yes, that's the total. This is the total. This is the total number of repeats, right? Total number of repeats, and we want to know in that many repeats. So J is the number of separations, right? The number of separations allowed. And with 3 separations, yeah, J is the number of separations. So we used 1 separation, so it have to be -1. So we go in there and -1. That's the number of separations we can do. Okay? Number of separations. And then we get that. When we get that, so temp, blah, blah, blah. And then, well, J, let's say temp.append, we're going to append a 0. And then temp -1 plus equal to this, right? And then K goes up. Yeah, that's fine. And then still J -1, blah, blah, blah. We handle, right? Once we're done with this, temp.append 0. And because we use J -1, ooh, it has to be. Dang it. We have to fulfill the rest. Yep, we need to fulfill the rest. So this is going to be a long list. How long can it be? At most 10 to the 5th. It's going to be a long array, but I don't see any other way. Yeah, we can stop. That's the same thing. I kind of want to just try this. Then we have to reverse it. I don't know about that, man. I don't know about that. Yeah, let me just do this. I think I'll benefit more by doing this. Nope, I think it just times I. Yep. And then for J in range -1, this basically we can say instead of append, we say temps J equal to. Okay? Because we start from I -1, which is exactly what it is. Right? We start from I -1. And then go all the way down to the last one, the J. And then J minus equal 1. And then we can say our J. We're going to do this. So what is this thing? Well, this shall be j, right? So temp j plus equal to temp this, right? J minus 1. Yes. Minus k, blah, blah, blah. So, blah, 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 when we're done, and then we say if, now I can say for let's call for m in range j minus 1 to 0. Okay, j minus 1 to 0. And this is going to be temp m. And say if not temp m, it's already 0. Then we break it. We don't have to keep going. So now we produced that. Lib gonna append some temp, okay, and dp dot pop left and dp dot append temp. Then go again. Once we're done, return lib. All right. So this one we can just say build self dot build lib. Oh, I forgot the self. So self dot build lib max length. We have max length 4 and max repetition is 4. And this is self dot build lib max length 3 and 3. So now we build it. Okay, we build it. Now what do we do? Well, now we have res equals 0. Actually, yeah. And then we say for again k l in keylen if key in 7 or 9, right? Then oh, hold on. Is this multiplied by this? Multiplied. It's multiplication. Okay, it's multiplication. Then that your res should be 1, right? Then res equals res times lib 4, right? And key. Well, have int key. Okay. This times this and mod. I'm not sure if we need a mod here, but maybe we should. Yeah, this thing can grow big as well. Multiply. Not so sure. I don't know. Should we append this mod, and then this equal to temp m plus this mod. So all the plus we mod. How about this? Do we mod these? You gotta be kidding me. So it's this thing mod. So everything mod. Okay, we mod some mod. Okay, and then this is this times this, we mod. So else equals res times lib3, right, int k and mod. So blah blah blah, then we return res. Okay. Oh, this is not sure. It's so convoluted. Made me feel like there gotta be a easier way. Alright, so same thing, same deal. We're gonna try it. Tuple is not callable. Where? Oh. Mod is not defined. Right, of course the mod is not defined. Shoot self dot mod. Let's do this. Mod self dot mod. Run. Ew, that's ugly as hell. How is the first one failing? Everything returned 2. What? What? I'm returning a max length. Oh, hold on. There's a lot of things is wrong. We will solve this one by one. Okay, I'm still in the mood, so let's see. So let's print key length. See, so 2 is the 1 length, which is fine. Right? You know what? We can just do int here, and we don't need these here. I know we don't need these int. Okay. So this is fine. Let's see. Oh. Now we can print lib4 and print lib3. Yeah, lib4 and lib3 is the same thing. And now for key and key length, that'll be 2, right? And oh, it's now key, it's length. Alright, it's my bad. It's my bad. We got length and key confused. Okay, now let's try it again. So we pass the first, of course we pass first, but this one. So it's the logic. Something with the logic is not sound, which is fine. You just no need to work on it. K is fine. Now this lib3, I don't think that's correct. 0, 1, 2, 4, 10. In 10 should be 7. Okay. So what happened there? Yeah, let's observe. Let's observe the temp, changing the temp. Okay. The temp is supposed to be. Yeah, let's comment out the other things so it won't kind of pollute our vision. 0331. The temp is absolutely correct. So temp here is correct. Let's put J as well. So J is to 1. And this shall now run. Right? If we do here, if we say print temp, ooh, this is not right. Do we have an M? Well, hold on, let me think. Yeah, we do have an M because Y can take 0. Do you want M to take 0? I do not want M to take 0 because if we can take 0, we shall take 0 here already. Yeah, this should not take 0. I do not want it to take 0. Okay, so now let's try it again. 13 is not right. Again, this is the only thing we care about. 7 and 17. It's not supposed to be 17. It's supposed to be 13. Okay, so something is wrong. Something is wrong again. So we have. Are we running? Wait, what the hell? Oh, shoot. That should be max length, right? Wait, what the hell am I doing? No, this is right, this is right. This is I. So after that, I probably should print dp as well. Okay, so dp now becomes this. That is correct. Next one. 11121030 should be 02641. So this is the wrong one. How did I get a 6? No, this 6 is right. And the last one here is this one. This one's not right. This one's not right. Okay, let's calm down and then we just figure it out. So K, right, is a 1. So we say, so what is J? At the end of J, coming out is 2. So we go from 1. We can only take 1, right? So M is 1. So now K is going to be 1 to 3. So at that time, K is here, minus 1, right? Shall be 0. Shall be 0. Minus 1, minus 2, minus 3 shall be 2. How did you come up with 6? First one take us 3. How dare you take 3? Well, what the hell is M? M not supposed to be. M is supposed to be. What's J here? J here is. J here is 2. 2. So max length is 5, right? So just go 4, 3, and 2. Yes. 4, 3, and 2. And then M coming in is 1. M coming in is 1. Hold on. M coming in. I think this is not J. But M is 1. That's actually correct. M is 1. But that's not J. That's M. Because J is gone, we're thinking about M. M is the current number of separations we can have. And then we take 1. So this is right. Oh my god, look at all the print statements. I'm not kidding. This is so bad. The official solution better be nice. Alright, let's do again. These are right. Okay, so we have some confidence to bring this to the test. Okay, so for test, definitely we have to do something crazy with 7, right? We're going to do something 7. Well, actually 7, 9. Actually, we'll just do this. How many? Oh, we can do as many as we want. Just run it. What did I do? I probably put. Did I put a? Yeah. Oh, I put a 1. I think we have it. Let's go. Let's go. Let's go. Doesn't seem promising. It is correct, but we oh my god. Okay, what do we do? What do we do? I'm not deleting this one. It took me so long kind of come up with this, but I'm also not writing any comments about this. I don't know, this is just, I will not understand this. This is TLE. Difficulty is to compute the number of options. You know what? I don't know. Maybe depending on how they call it, right? I'm gonna cheat. Oh, I'm computing everything from the start every single time. No, but I'm trying to shoot. 3 build lib Can you just build it once instead of build it twice? But the lib will be different. That's why I need to build it twice. Ten to the fifth. Okay, max length 10 to the fifth, 3. Lib 4. 4. And this does not exist. I don't know. No, don't do this. What? I define here. Did the class go wrong? Hmm? Oh, I need to define this first. Now we see the problem. This one's too slow. So we need offsets. Okay, let's cancel. Let's call it today. Let's call it today. I think I just need to update this function instead of doing this. Alright, this is the max length. This is going to be tremendously long. We do have to append. But we also need to have an offset. So we know when it goes beyond, it's going to be 0. Oh man. Yep. First index. I want to keep trying. I don't think that's the end. I think we definitely have a shot at this. And yeah, let's end it right now. Oof, tough one. Yeah, I'll try tomorrow. I'll see you guys tomorrow. Adios.